Astrophysicist Neil deGrasse Tyson, well known for his contribution to public science literacy, has compelling reasons to believe that the San Andreas Fault may crack soon. His views, grounded in scientific observations, offer an insightful look at the precarious balance between Earth's geologic processes and human existence. Number 1. Tyson's observations on increased seismic activity. The heart of Tyson's argument regarding the impending movement of the San Andreas Fault is founded on the observable increase in seismic activity in and around the region. While Tyson is an astrophysicist, his broad scientific background and acute awareness of the interconnectedness of various scientific disciplines allow him to provide educated insights into the field of seismology. Tyson cites increasing frequency and magnitude of tremors detected in the area as the first indicator. This seismic activity, although often too subtle to be noticed by local inhabitants, is closely monitored by seismologists. As these minor quakes become more frequent, they might be an indication of the fault accumulating stress. This stress, Tyson points out, is being stored up in the tectonic plates on either side of the San Andreas Fault, acting like a ticking time bomb. With each passing day, more and more pressure builds. This pressure is only released through earthquakes. According to Tyson, the increasing rate of tremors suggests that the pressure is reaching a critical point and might result in a significant seismic event in the near future. Tyson also highlights a study by U.S. Geological Survey, USGS, which discovered a fascinating yet terrifying trend. The USGS research indicated that the period of seismic silence, or the duration between major earthquakes along the San Andreas Fault, has been shortening. This means that the time intervals between significant seismic events are getting smaller, a trend that Tyson sees as another sign of an imminent large-scale earthquake. Seismologists have come to understand the behavior of faults like the San Andreas over many years of intense study. Tyson believes that the patterns discovered by these scientists, such as the evidence of previous massive earthquakes in the geological record of the area, suggest that the San Andreas Fault follows a kind of schedule. According to this perspective, the fault is overdue for a significant quake. The unique feature about Tyson's observations is his ability to explain complex geophysical phenomena in a manner that is both accessible and engaging to the public. He discusses the issue with his usual charisma and conviction, driving home the reality of the potential disaster. But despite the gravity of the situation, Tyson also ensures that his audience understands that this is not a cause for unnecessary panic. It's a call for readiness and for understanding the natural world in which we live. Tyson's observations on the increased seismic activity along the San Andreas Fault line underscore the pressing need for preparedness. He shares his insights, not to incite fear, but to encourage proactive measures and increase public understanding of this significant geological threat. With a balance of scientific knowledge and thoughtful consideration of human impacts, Tyson presents compelling reasons to pay serious attention to the San Andreas Fault's rumblings. Number 2. Understanding plate tectonics and its relevance. To understand Neil deGrasse Tyson's perspective, one must first grasp the fundamental concept of plate tectonics. Earth's crust is divided into several large and small sections known as tectonic plates. These plates float on the semi-fluid layer of the mantle beneath them, and their movements, albeit slow, result in significant geological events such as earthquakes, volcanic activity, and the creation of mountain ranges. The San Andreas Fault is a boundary between the Pacific and North American plates. Tyson's insights into the potential of a major earthquake in this region are deeply intertwined with his understanding of the tectonic movements occurring along this fault line. The Pacific Plate and the North American Plate slide past each other in a horizontal motion, making the San Andreas a transform fault. This horizontal movement, while seemingly benign compared to the destructive vertical movement seen at convergent boundaries, where plates collide, can generate powerful earthquakes. As Tyson often points out, the most crucial element to consider in this tectonic puzzle is the rate and direction of plate movement. The Pacific Plate moves northwest relative to the North American Plate at a rate of about 56 millimeters per year. Although this may seem trivial, the cumulative effect over the decades can cause immense strain. The sheer scale of these forces is where Tyson's background in astrophysics adds value. While the field of seismology provides the data and observations about the faults and their movements, Tyson's expertise allows him to conceptualize and communicate the enormity of these otherwise abstract geological forces. The constant movement of the Pacific and North American plates leads to stress accumulation at their boundary, which is periodically released as seismic energy in the form of earthquakes. However, if the movement along the fault is hindered due to friction, stress continues to build until it eventually overcomes the frictional force, triggering a significant quake. Tyson has emphasized that this ongoing stress accumulation is a crucial factor to watch out for. In Tyson's view, understanding plate tectonics is not just an academic exercise. It provides valuable context that helps us appreciate the scale and inevitability of geological events, thereby encouraging more informed planning and decision-making in relation to earthquake preparedness and response. Number 3. Neil Tyson's views on historical earthquake patterns. One of Neil deGrasse Tyson's reasons for believing that the San Andreas Fault will crack soon is his interpretation of historical earthquake patterns. Tyson is a keen observer of patterns in nature, a trait which is common among astrophysicists, given their work in studying the cycles and patterns of celestial bodies. This skill is applicable in the study of seismic activity, where historical patterns often serve as indicators of future occurrences. The San Andreas Fault, for instance, has a history of significant seismic activity. The 1906 San Francisco earthquake and the 1857 Fort Tejon earthquake are two of the most notable events attributed to this fault line. These earthquakes, both estimated to be over magnitude 7, were a direct result of the stress accumulated along the San Andreas Fault due to the movement of tectonic plates. Tyson notes that the intervals between such significant seismic events suggest a certain pattern. Studies indicate that large earthquakes along the southern section of the San Andreas Fault occur roughly every 150 years. Given that the last substantial earthquake in this region was in 1857, Tyson points out that we're overdue for another one according to this historical pattern. However, Tyson also emphasizes that while historical patterns can suggest a possible timeline, they do not provide a definitive forecast. The nature of tectonic plate movements and the resultant seismic activities are incredibly complex and influenced by various geological factors that are still not entirely understood. By sharing his insights on historical earthquake patterns, Tyson aims to drive home the importance of understanding and respecting the power of natural geological processes. His discussion of the past seismic activities along the San Andreas Fault serves as a warning of the potential future seismic event that the region might experience. His approach urges us to study these patterns closely to prepare for the possible repercussions rather than be caught unawares. Number 4. The role of stress accumulation according to Tyson. Neil deGrasse. Tyson's consideration of stress accumulation along the San Andreas Fault forms a central aspect of his perspective on the impending seismic event. Tyson, with his acute understanding of physics and the forces of nature, provides an insightful viewpoint into how the accumulation of stress at tectonic boundaries can lead to earthquakes. The stress accumulation Tyson speaks of refers to the buildup of potential energy along the boundary where the Pacific and North American plates meet. The plate's movement is not smooth. Instead, it's more akin to a start-stop motion due to the friction between them. When the plates stick at the fault line due to this friction, stress starts to build. This is akin to a loaded spring, storing potential energy. This built-up stress is eventually released when the plates overcome the frictional resistance, causing them to snap into a new position. The sudden release of energy results in seismic waves that we experience as an earthquake. The larger the accumulated stress, the more powerful the resulting quake. This accumulated stress, according to Tyson, is not something that can be mitigated or prevented. It's an ongoing natural process that occurs due to the inherent movement of tectonic plates. Therefore, he emphasizes the importance of preparedness and understanding the nature of these geologic forces rather than futile attempts to stop them. Another significant aspect that Tyson addresses is the uneven distribution of stress along the fault. Certain sections, known as asperities, are more resistant to movement and hence accumulate more stress. These areas are often the origin points of significant earthquakes. Identifying and studying these stress points can provide valuable insight into where a potential earthquake could initiate. Tyson's interpretation of the role of stress accumulation in predicting the San Andreas Fault's activity emphasizes the importance of understanding these natural processes. In his view, comprehending these geologic forces not only equips us with knowledge, but also fosters respect for nature's power. This comprehension is a prerequisite for effective preparedness strategies and underlines the urgency to act, considering the stress that has already accumulated along the San Andreas Fault. Number 5. Tyson's considerations on infrastructure vulnerability. When discussing the potential for the San Andreas Fault to crack, deGrasse Tyson also highlights the profound implications such a geological event would have on existing infrastructure. Infrastructure vulnerability in the event of a significant earthquake is a topic of substantial concern, especially in densely populated and developed regions such as California. Tyson explains that the built environment, our cities, towns, and the infrastructure that supports them, are not designed to withstand the forces released by a major earthquake. While modern building codes consider seismic activity and have regulations in place to guide construction in earthquake-prone areas, the vast majority of structures were built before these standards were implemented. Tyson also considers the potential impact on transportation infrastructure. Damage to highways, bridges, airports, and seaports could cripple mobility, severely hampering rescue and recovery efforts post-earthquake. The economic implications of such disruptions could be staggering and extend far beyond the immediate region due to the interconnectedness of today's global economy. Tyson's perspectives on infrastructure vulnerability are not merely critiques. They carry an implicit call to action. He advocates for incorporating seismic safety measures in existing and new infrastructure, particularly in high-risk areas along the San Andreas Fault. He supports the upgrading of older buildings to comply with modern seismic safety standards and the use of innovative engineering solutions to make infrastructure more resilient. Through his discussions, Tyson underlines the importance of understanding that the Earth is a dynamic and ever-changing entity. He argues that our built environment needs to respect and account for these changes rather than ignoring or attempting to resist them. Number 6. Climate change and earthquakes. Tyson's perspective. deGrasse. Tyson's observations on the potential cracking of the San Andreas Fault also extend into the realm of climate change. While traditionally considered as separate scientific disciplines, Tyson draws intriguing connections between seismology and climatology, emphasizing how interconnected Earth's natural systems truly are. Tyson points out that climate change could indirectly influence seismic activity. His perspective is rooted in the understanding that human-induced climate change is causing shifts in the distribution of mass on the Earth's surface, primarily due to the melting of glaciers and polar ice caps. This redistribution of mass could potentially affect the Earth's crust, leading to increased seismic activity. One of Tyson's primary concerns lies in the phenomenon known as isostatic rebound. This is the process where the Earth's crust, relieved of the enormous weight of melted glaciers, springs back or rebounds into its original shape. This shifting of the crust could contribute to the release of pent-up stress along fault lines, triggering earthquakes. He also discusses how climate change-induced sea level rise might impact seismic activity. The additional weight of the rising sea levels on tectonic plates could alter stress regimes along certain fault lines. While the San Andreas Fault may not be directly affected by this, given its inland nature, it underscores the complex interactions between different Earth systems that could influence seismic activity in various regions. Through these discussions, Tyson is quick to clarify that while climate change and human activities may have an influence on seismic activity, they are not the primary cause of earthquakes. Tectonic forces remain the dominant factor. Nevertheless, understanding these potential influences is crucial in our rapidly changing world. Tyson's perspective on the intersection between climate change and earthquakes is an invitation to view Earth as a complex, interconnected system. His insights encourage us to broaden our understanding of seismic activity, considering all potential influencing factors, not just the obvious ones. As we navigate the twin crises of climate change and seismic hazards, such holistic understanding is not just beneficial, it is essential. Number 7. Tyson's examination of human-induced seismicity. In the context of predicting seismic activity along the San Andreas Fault, Neil deGrasse Tyson also focuses on the role of human-induced seismicity. Human-induced or anthropogenic seismicity refers to earthquakes and tremors caused by human activities that alter the stress conditions in the Earth's crust. Tyson highlights several activities that can contribute to human-induced seismicity. One of these is the extraction of natural resources such as oil, gas, and coal. When these resources are removed from the Earth, it can change the stress distribution in the crust, leading to ground subsidence and potentially triggering seismic activity. Tyson often refers to instances where mining activities have been directly linked to seismic events. One specific process Tyson frequently discusses is hydraulic fracturing, or fracking, which involves injecting high-pressure fluid into the earth to extract natural gas or oil. This process can induce seismic events, typically of a relatively low magnitude, but occasionally more significant quakes have been reported. Tyson also points out that the disposal of wastewater from oil and gas extraction into deep wells, a common practice in some regions, can induce seismic activity. The injected water can increase the pore pressure in the rock, effectively lubricating the fault and making it easier for the stored tectonic stress to be released in the form of an earthquake. Another form of human-induced seismicity that Tyson examines is the filling of large reservoirs behind dams. The vast weight of the water can alter the stress on the underlying crust and induce seismic activity, a phenomenon known as reservoir-induced seismicity. He highlights that these human-induced seismic events demonstrate how significantly human activities can interfere with the Earth's natural geologic processes. Tyson's discussions on human-induced seismicity extend beyond a mere academic exploration. He uses these instances as a call to action for more responsible management of our natural resources and environment. Tyson emphasizes the need for more sustainable practices in industries such as mining and oil extraction, and for stricter regulatory oversight to prevent the undue triggering of seismic events. Though Tyson doesn't argue that human-induced seismicity will directly cause a major quake on the San Andreas Fault, he insists that we should consider its implications as part of a larger conversation about earthquake preparedness and environmental responsibility. He suggests that as we continue to interact with and change our environment, we must consider all possible consequences, even those as seemingly unrelated as increased seismic activity. Number 8. Technological predictions and Neil Tyson's skepticism. In conversations about the potential cracking of the San Andreas Fault, Neil deGrasse Tyson often addresses the subject of earthquake prediction technology. Although technology has played a substantial role in improving our understanding of earthquakes and our ability to respond to them, Tyson retains a healthy skepticism when it comes to the idea of accurately predicting when an earthquake will occur. While Tyson acknowledges the leaps and bounds made in seismological technologies, from advanced ground movement monitoring systems, improved seismic wave analysis techniques, to more sophisticated computer models of tectonic behavior, he cautions against over-reliance on these tools for precise earthquake prediction. Tyson's skepticism is rooted in the inherent complexity and variability of the Earth's geologic processes. Earthquakes result from the interplay of a myriad of factors and occur in a nonlinear system, making their exact timing and location incredibly challenging to predict with high confidence. While our technology can provide useful data and valuable insights, it cannot entirely account for this complexity. He also draws attention to the dangers of false positives and negatives in earthquake prediction. An incorrect prediction of a major earthquake could cause unnecessary panic and substantial economic fallout, while a missed prediction could lead to devastating loss of life and property. As an astrophysicist, Tyson is all too familiar with the challenges of making predictions in complex and dynamic systems, and he urges caution in this regard. However, Tyson's skepticism about earthquake prediction does not extend to earthquake preparedness. He wholeheartedly endorses the use of technology in developing early warning systems, which can provide precious seconds to minutes of warning after an earthquake begins but before the shaking arrives. These systems, Tyson notes, can save lives by giving people time to take protective actions. Moreover, Tyson encourages technological advancements in building design and construction techniques to make structures more earthquake-resistant. From base isolation techniques to the use of flexible building materials, Tyson advocates for innovative engineering solutions that could significantly reduce the damage caused by earthquakes. Tyson's perspective on technological predictions encapsulates his scientific integrity and pragmatism. He emphasizes that while our tools and technology can and should be used to understand and mitigate the impact of earthquakes, we must also recognize their limitations. Number 9. Tyson's views on preparedness and disaster response. Neil deGrasse Tyson, in his discussions about the likelihood of the San Andreas fault cracking, dedicates significant thought to the topics of preparedness and disaster response. Drawing on his extensive scientific background and his understanding of societal dynamics, Tyson provides insights into how individuals, communities, and governments can better prepare for and respond to significant seismic events. Firstly, Tyson advocates for personal preparedness. He suggests that individuals should have a clear understanding of the risks they face and the steps they can take to protect themselves and their property. This could involve securing heavy furniture, creating a disaster kit with food, water, and medical supplies, and formulating a family emergency plan. At the community level, Tyson emphasizes the importance of education. He encourages schools and community organizations to provide information about earthquake safety, such as drop, cover, and hold-on drills. He further points out the value of community resilience, which can be strengthened by fostering strong social connections and networks that can be relied upon in the aftermath of a disaster. Tyson also discusses the role of governments and institutions in earthquake preparedness and response. He argues that they have a responsibility to enforce and update building codes to ensure structures can withstand seismic activity. Additionally, they should invest in infrastructure that is designed to be resilient in the face of an earthquake, such as reinforced hospitals, fire stations, and emergency operation centers. Beyond the physical infrastructure, Tyson also discusses the necessity of robust disaster response plans. These plans should include effective communication strategies, evacuation procedures, and resource management plans. Tyson emphasizes the need for these plans to be flexible and adaptable, as the specific circumstances of each earthquake can vary significantly. However, Tyson's views on preparedness and disaster response extend beyond these practical considerations. He also discusses the psychological aspects of dealing with disasters. He encourages a mindset shift from fear to understanding, arguing that a deeper understanding of seismic activity can help people feel less afraid and more prepared. He often reiterates that earthquakes are natural phenomena, part of living on a dynamic planet, and that understanding them can help mitigate their effects. One particularly compelling aspect of Tyson's approach to disaster response is his emphasis on the role of science. He advocates for continued research into earthquakes and tectonic activity, insisting that science is a critical tool in our efforts to safeguard ourselves against natural disasters. Finally, Tyson promotes the idea of learning from each seismic event. Every earthquake provides valuable data and insights that can be used to refine our understanding of these natural phenomena and improve our preparedness and response strategies. Number 10. The influence of mass media and misinformation, Tyson's criticism. When discussing the possibility of the San Andreas fault cracking soon, Neil deGrasse Tyson frequently addresses the role of the mass media and the proliferation of misinformation. Known for his science communication skills, Tyson considers accurate, effective communication to be a vital tool in shaping public understanding of complex scientific topics, including seismology. Tyson's criticism of media and misinformation revolves around several key points. Firstly, he observes that the media often sensationalize earthquake predictions, focusing on extreme scenarios that might grab headlines but do not accurately represent the scientific consensus. He notes that this sensationalism can lead to unnecessary panic and confusion among the public. Tyson also criticizes the prevalence of pseudoscience in media coverage of earthquakes. This includes baseless predictions, unsubstantiated theories, or misinterpretations of scientific data. Tyson warns that such misinformation can not only mislead the public, but also erode trust in legitimate scientific findings and predictions. Moreover, Tyson critiques the media's tendency to present scientific uncertainty as a lack of understanding. He emphasizes that uncertainty is a fundamental part of science, reflecting the complexity of natural phenomena and the ongoing nature of scientific discovery. Misrepresenting this uncertainty can further contribute to public confusion and skepticism. However, Tyson's criticisms are not limited to the media. He also reflects on the scientific community's responsibility to communicate effectively with the public. Tyson acknowledges that scientific jargon and complex concepts can be challenging for the general public to understand. He advocates for scientists to improve their communication skills and to engage with the public and the media to ensure accurate representation of their work. Furthermore, Tyson stresses the importance of media literacy among the public. He encourages individuals to critically evaluate the information they consume, to seek out reputable sources, and to understand the difference between a single study or opinion and a widely accepted scientific consensus. Despite his criticisms, Tyson recognizes the power of the media as a tool for science education. He often leverages his own media presence to clarify misconceptions, explain scientific concepts, and advocate for evidence-based decision-making. Through his various media engagements, Tyson seeks to foster a more scientifically informed and curious public.